Hello again. In this video, we're going to go over the average value of a function on a closed interval from a to b. So here's the definition of the average value of a function. The average value of an integrable function f on the closed interval from a to b is given by this formula. It's 1 over b minus a times the definite integral of f of x from a to b. And we denote the average value of a function by putting a bar on top of it. So f bar is the average value of f on the closed interval from a to b. That's how we denote it. Okay, let me show you why this formula makes sense. So suppose you have some function, the graph of it looks something like this on this interval from a to b. Now when you find this definite integral of f of x from a to b, you're finding the net area that's trapped in here. Now what we're going to do is we're going to maintain that same amount of area, but we're going to flatten the function out so that it's horizontal, perfectly horizontal. And wherever that is going to be known as the average value of the function on the interval from a to b. Okay, so if you flatten this function out and keep the same amount of area that's in here, this little green area, then it would flatten out right here. And that's the average value of f on this closed interval from a to b. Notice that the area in this little rectangle is the same as the area that's trapped underneath this function from a to b. Okay, and if you find the area of this little rectangle, the area is just b minus a, which is the width, times the height, which is f bar. Okay, so when you multiply those together, you get the area of the rectangle, which is the same as the area trapped underneath this function, starting at a and ending at b. So these are equal, right? This is the area of the rectangle, and this is the net area trapped under the function from a to b. And then if you divide b minus a to the other side and isolate f bar, that's where you get this formula from. That's why f bar is equal to 1 minus b over a times this definite integral. Okay, so let me show you an example where we use this. So let's find the average value of x cubed on the closed interval from 0 to 4. Now the graph of x cubed looks something like this, and we're looking at the average value of this function only on the interval from 0 to 4 in here. Okay, so here's the formula for average value of f. Notice that a is equal to 0 and b is equal to 4. So we get 1 over 4 minus 0 times the definite integral from 0 to 4 of x cubed. Okay, now notice that x cubed is continuous on the closed interval from 0 to 4. And so because of that, we can evaluate this definite integral using the fundamental theorem of calculus. Now remember, in order to do that, we have to find any antiderivative of x cubed. Of course, x to the fourth over 4 plus any constant. That's the family of antiderivatives. Remember, you add 1 to this exponent, and you get x to the fourth, and then you divide by the 4. Then the whole family would include all the possible constants, so plus c. Now, we just need any antiderivative, so we're just going to let c be 0 to make this as easy as possible. So let's use x to the fourth over 4. Okay, we just need one antiderivative. That's, again, the easiest one to use. And then to evaluate this definite integral, we just have to find f evaluated at 4, the upper limit, minus f evaluated at the lower limit, which is 0. Don't forget that all of this is going to be multiplied by this 1/4 that sits in front of this definite integral. Okay, so f of 4, we get 4 to the fourth power divided by 4. Of course, f of 0 is just 0. And then when you multiply that by the 1/4, notice you have 4 to the fourth divided by 4 squared, which of course is just 4 squared, okay, which gives you 16. Okay, so that's the average value of this function on the interval from 0 to 4. So if we look at the diagram, again, when you find this definite integral right here, you're finding the area that's trapped, that area that's trapped between the function and the x-axis. Right? In this case, it would be the area in here. Okay, and if you look at that, right, this is f of 4 minus f of 0. And when we calculated that, we got 4 to the 4th over 4 minus 0, which is just 4 cubed. Okay, and that's equal to 64. So that's the area trapped in here, right? It's equal to 64. And so what we've done is we've flattened out the function so that it remains perfectly horizontal. And we determined that that would have to be at 16. Okay, and if you find the area in this little rectangle right here, okay, that area in there should also be 64. It is, because the width here is 4 units long this way and 16 units high this way. Okay, and so if you find the area of that little rectangle, you can see that it's equal to 64. Okay, so again, if you want to keep the same amount of area that's underneath the function, which is 64, then you would have to flatten the function out at 16 in order to maintain the same amount of area in there, right? Namely 4 times 16, which is, again, 64. Okay? So that's how this little formula works, right? You can sort of interpret it geometrically in the way that I've shown here. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.